think today class is up to 4, I said already. 4 o'clock, just we have 1 hour, 45 minutes. By 4 o'clock sharply, I have to stop the class today. So tomorrow timing, we are around 8 o'clock morning, again I'm telling. Morning 8 o'clock is the class, not 9 o'clock. Message karo ek baar, 8 o'clock timing. Tomorrow morning is also 8 o'clock. Okay? So very good afternoon, we'll start the next part. So we have completed the approximate models and how the links will be, everything we have covered. Let us start the MOSFET model, how to do it. So continue with the MOSFET model. There is a MOSFET amplifier model. Keep the heading MOSFET amplifier model. Hardly takes 10 minutes to understand this. Try to see. This model, how to create means, first of all, BJT model, just see here, BJT amplifier model. Recollect the BJT amplifier model. That also specifically not all the models. Just I want to represent my RPi model. Observe this model, RPi model. In this model we have seen input side we are taking here. Input side we are taking here RPi. Input voltage we are taking as VPi. And output side we have taken one current source GM into VPi. This becomes collector and this becomes your emitter. So this is your BJT common emitter amplifier model, which is called RPi model. So there is some similarity for RPi model to MOSFET model. So you can see the similarity. The same model if I want to represent for MOSFET, what is the difference here is, if I go for MOSFET now, MOSFET amplifier model, MOSFET amplifier model, just only you have to do is, this is a gate you have to take and this will be source. He is telling that VGS, to take it as open in the model. So he has done like this. The input side, you have RPi here in BJT class, but in MOSFET class we have open here, because we already know that the gate current to the MOSFET will be 0 in the classes because of MOS metal oxide semiconductor. So no current will enter, no current will come out because of oxide layer. That's why here in AC model, it may be GFET or MOSFET, whatever maybe, you can take it as open there. So that is the easiest way of understanding the model. So in BJT classes we represent RPi as an input impedance. In MOSFET class we represent infinite impedance in the class. We represent it as infinite impedance. Okay. The next output side, we have a current source here also. That's called drain current, which is represented here. This current is IC current. This current is IC current. This current is GM into VGS, we can write, which is a drain to your source. And this current we can take it as ID current, which is called drain current. So if you see that this is the similarity between these two models, and this model will become common source amplifier model. This becomes the common source amplifier model. So today classes, whatever I teach, we are going for approximate model study purpose. This models I am using. One of the easiest models to do the problems. Hardly takes a matter of time to remember these two techniques. Input side, if it's a BJT, we write RPi as an input impedance. Output side, a current source GM into VPi. If it's a MOSFET class, input impedance is open, output impedance is GM into VGS. That will be the story. So this completes the total model theories now. Okay, BJT how, three theories. MOSFET how, a unique theory came from BJT theory to MOSFET. Comparison wise, we got the modeling. So it's just a comparison wise, we got the idea how to write the model for it. A very good afternoon to everybody. Please complete it. So today my journey will start with my second topic. I think topic number 3 we can enter. 2 topics we have covered now. This may be second topic in our schedule. First topic is BJT amplifier models we covered. This is second model. Second concept is MOSFET amplifier models we covered. Now today class we are entering to the topic number 3. That is called common emitter, common source, bypass amplifier, how to analyze. One of the important topics of analysis. Now let us see step by step how to develop it. You can do the problems very well if you can understand the theory what I am explaining there. Okay. Main work is completed. Now smoothly you can complete the concepts now. So every time when I teach my classes, okay, I take this model because this looks similar to this model. For easy to understand the two devices at a time parallelly, this model is better for you. Okay. Let us take RPi model to analyze the complete picture for both the models. And if you want to do the problems in another models, we just convert it. Nothing is there. In place of RPi, if you want to have RE model, you want to just repeat RE, you substitute and get the answer. If you want HIE, just substitute HIE, you will get the answer. Just only conversion you have to do it. Okay. If you do the conversion, problem is completed. So with this, we'll start our topic number 3. Topic number 3. Keep the heading. Next topic. Topic number 3. Common emitter and common source. Bypass amplifier. Common emitter, common source, bypass amplifier. First student should know what do you mean by bypass. That knowledge we'll try to develop. I'll take some amplifiers here, try to understand how it looks like a bypass. Common emitter, bypass. I'm giving some examples for you. See here. Common emitter, bypass amplifier. If I want to draw a common emitter, bypass amplifier, it looks like this. I have taken a transistor here. Suppose we have RE resistance, and I kept here one capacitor. We are giving some technical name for this, CE capacitor. I'll tell you why CE, all these things in the next step. First we'll complete the part. There is one capacitor will be there technically here, CE. And we have one resistor here, RC. Next we have some biasing we are taking. This is RB, VCC. We have some capacitor here, CC. This is your input. There is a capacitor here, CC. This is your output. So perfectly to see, nothing you have done. When you want to make an amplifier, the only thing is extra capacitors you are attaching to the biasing circuit. Already in the previous class we know biasing circuits. Just pull connect some capacitors like this. CC, CC, CE. There are 3 capacitors you are seeing in the board. These capacitors if you attach, then signal you can apply it and you can take the output is telling. That becomes an amplifier in the class. So if you want an amplifier, capacitors will play the role there. Okay, if you don't keep the capacitors, what happens? I'll teach you in the next step. At this point, capacitors are there. Okay, this is the point first keep in mind. There are 3 capacitors playing the role in the amplifier. So what is the meaning of CC, CE? Of course I'll tell you. First names first we'll understand how to write the name of capacitors. Here I'm writing CC means indication. Coupling capacitor we call. Technically these people will call coupling capacitor. CC means coupling capacitor. And CE means bypass capacitor we call. These are the two names I can give. One is coupling capacitor and one is bypass. Here we have two coupling capacitors. One bypass capacitor is there. Okay. The next point, if I try to write here side by common source bypass, if I want to study common source bypass, it looks same idea. So both are similar. That's why parallel we can study. This is my input, MOSFET. This is your RS. This is your CS. This is RD. This is R1. This is R2. TD. So you can see both look similar to each other. The only thing is here also, if you want, you can make a voltage divided bias. If you want, you can make here also, so that they look similar to each other. This is R1. You can keep some R2 here. You can keep this biasing so that you can see both look same. The others, the wait karo, coupling capacitor meaning, everything beautifully I'll explain you. Don't worry. First write the names. In the next slide, I'll explain you the complete approach. Okay, because every time I have to use that capacitors in my class without knowing how can I teach. I'll explain you. Don't worry. First write whatever I'm writing in the board. You write the points. First observations are important here. So here, CC here also the name CC is called as coupling capacitor. CC is called coupling capacitor, and here CS is called bypass capacitor. CS we call bypass. That CS means a source capacitance. The source capacitance will work as a bypass capacitor. Here, C emitter will work as a bypass capacitor. So I think we'll have two coupling capacitors, one bypass capacitor, and the amplifiers. Okay? Why the capacitors are used in the next slide, I'll explain you the importance of that. At this moment, please note on these 2 points. So what you have to do in these concepts, that is important. Why this is called bypass? That point first I must be able to understand it. So the only rule for this is bypass. Anybody use this word bypass? If I use this word bypass, what is the condition for this is? Condition for bypass is simply in AC analysis, in AC analysis, your RE or RS should be 0. You can see here, this one point is most important to understand a bypass systems. What is telling is, when you are doing the circuits in AC analysis, your RE, capital RE, that is emitter resistance, or maybe a source resistance there should be 0. That should happen. So how it is happen? Here I am seeing here RE in both sides, but he said in AC analysis it should be 0. For example, I'm doing. For example, if you see here in this transistor we have RE. In this transistor we have RE is there. But what you said is AC analysis. Whenever you are talking about only AC analysis, can I say that the capacitor CE will become short circuit? You know that in AC analysis, all the capacitors will assume as short circuit, but DC analysis will be working as open circuit. In my first classes, when I'm teaching peak detectors, at that time I have given some properties of capacitors. So don't recollect it. Again, don't think, sir, why he has written short. Capacitors will work as a short circuit for AC analysis. They will work as an open circuit for DC analysis. That means this capacitor CE will become short circuit whenever you talk about AC analysis. Okay? Okay? AC analysis, this capital RS should become 0. At this capacitor, when you make short in AC analysis, what happens is this model will become simply like this. Simply, it will become short. So you can see, whenever there is a resistor parallel to a short circuit, then automatically the net equivalent will be a short circuit. So can you see now, because of the capacitor, your RE here became 0. So this is the way you have to understand whether the circuit is a bypass or unbypass. Bypass or unbypass is very easy. Bypass means RE should become 0. Unbypass means RE should not become 0. That means in the next class, this capacitor, if I leave it up in the model, it will become unbypassing. Unbypassing means what? RE resistor will play the role, which is nothing but a negative feedback will come into the circuit. You know that RE will play a negative feedback. So the negative feedback, if you don't want in amplifier design, just leave that RE effect. Okay? That bypass will nullify the feedback effect there. So that is the meaning of the concept. Sneha Kumari here. R2 you are thinking, I'm teaching here, you are talking here. R2 is not playing any role. R2 is a biasing circuit. Here our interest is RE. That RE is a negative feedback resistor in our class. In AC analysis, we don't want negative feedback. At the time, you can do like this instead. Suppose if you keep negative feedback, what happens? Your gain, voltage gain will reduce. If you want a good gain, negative feedback should nullify that. So I nullified by the capacitor called CE. That is the meaning here. So take this beautiful example to understand it. This is a good example to understand what you mean by bypassing. A good example for it. So if you want bypassing, just make the concept like this. So whenever I see RE parallel to CE, you can say the system name is bypassing. Okay? It's a bypass circuit. Yeah, both the CC also have the same concept, but we want to teach here. Bypass will come from this knowledge. Other things will be short only, but we are talking about here CE. Bypassing technique I am talking here. Yeah. So if you complete up to here, a student got a small information. What do you mean by bypass? Means this is bypass condition. RE or RS should be 0 for AC analysis. That is primary requirement. That can be done by keeping a capacitor parallel to RE and RS. Okay? So these are called bypass circuits we call. Now I'll I'll give the importance for a student. What is this bypass? Why should I take? And why should I take capacitors? All these issues I'll teach now within 15 minutes. We'll try to develop a concept based on this analysis now. Okay? You'll get a good clarity on the concept now. So please complete up here. The reality I'll explain you inside the circuit what is happening. In reality I'll show you. I'm just diverting my concept to understand what is coupling capacitors, why should I take, and why should I take bypass. I'll give clarity for you. Vishal, what is the meaning of bypass? The things will come in my explanation, don't worry. Okay? अभी next topic में वही बता रहा हूँ. What is a bypass? What is a coupling? क्यों बात कर रहे हैं? The things I'll explain. Don't worry. Every student will understand nicely the concept. Let's see. So if it is noted, please tell me. And one more thing, morning students has been given some complaint about 14th lecture. Okay? I think 14th lecture, part A. Some students have been messaged me that it's not opening. Is it happening for every student? Please reply. Only I think 3-4 students has been messaged me like that. Remaining students, have you got it or not? That is your yesterday class first video is testing, I think. Workbook solution video. That is coming for everybody or only 2 or 3 students? Because we checked that it has been correctly has been sent to you. Okay? Shavni Das is telling 14A is not opening. It is happening for me also, sir. Writing is completed. It's happened for all. My device is also not opening. So everybody, I think, have the problem this one. Correct? एक बार check कर दीजिए today. If it is not getting, we'll try to make it one more time. That we'll re-upload it. Okay? Yeah, CC cannot figure CN at the input. Workbook solution is opening. One person said opening. If you don't need the resistor, why are you not directly removing it? Ditya Das, don't कर सकते आप. Resistor you can keep, resistor you can leave it. Because there is some reasons for that. If suppose resistor directly if you leave it, directly short कर दे, वो भी कर सकते आप. But when you do like that, the circuits will become fixed biasing circuits. Fixed bias in DC analysis, they are unstable in nature. Correct? If you want to make it more stable, the resistor should be in DC analysis, it has to present. For AC, it has to become short. So we have 2 issues there. DC wise we want. AC wise we don't want. That is the reasons we kept like that. Okay? DC wise we want actually because for stabilization. For AC wise we don't want because gain is reducing. Okay, if it is not opening 14A, let us I complain with them. They'll try to re-upload it. No problem. Thank you. Thank you very much for giving the feedback. So let us see the main concept. Importance of coupling capacitor and bypass capacitors. Let us understand what is the meaning of CC and CA in amplifiers. You have to take a big diagram. In the total page you cover it because analysis will be done in the diagram itself. You nicely write on a big diagram like this in single page. Take a big page, total page. Develop this concept as a big diagram. Horizontally you write in the notes. It is better. This is CC here. Each and every step in the diagram I'll explain. See here. Next we have is transistor. We have RE here. Next we have capacitor. CE. Next we have is RC. Next we have is biasing circuit. This is R1. This is R2. Next we have is capacitor. CC. And finally you'll see some load. This is your RL. This is your output. You're trying to see this is VCC supply. So in reality, what is happening actually, I'll show you in this diagram. So this is actually your amplifier diagram. Okay? We're trying to see some biasing circuit with some coupling capacitors, bypass capacitors. Why should I give this capacitors? Why can't you apply directly the signal? So is there any technical problem? Let us understand. Okay? First point, I'll write some conclusions side by to start the class. See here. Side by some concept is important to develop this analysis. If I go for suppose DC analysis, means only DC part if I explain the concept. What are the conditions we have to take is your signal should be 0, AC should be 0, coupling capacitor and bypass capacitor should be taken as short circuit. We have to take SC, short circuit we have to take. Sorry. For DC it is not short, it's an open circuit you have to take. They are open circuit. That is open circuit. OC you have to take. If I go for AC analysis, the rule here is your VCC should be ground, coupling capacitor and bypass capacitor should be short circuit. And these principles please never forget here. With this the total game will be completed. Only these 2 points side by written. If you are doing some DC part first analysis, when you do some DC analysis, AC को ground कर दीजिए, superposition theorem we are applying. At the same time, the capacitors, whatever the capacitors you are seeing, make it open in DC part. Because in DC capacitors will be open. Okay, they will be open circuit. If you are going for AC analysis, your DC should be ground. The supply has to become ground. These capacitors should be short circuit we have to take. This common sense if you apply, first we start with the DC part first. If you start with the DC analysis, I take one color for DC currents. There is a yellow color, a green color I am taking. The current started from here, VCC. Can you see that one current started here to flow in biasing circuit? That is called IB current. IB current started to flow here. Okay, so whatever the current is flowing here is not IB here. Sorry, this current will be some I1 current will flow here. This is I1 current. This current whenever it comes here to the base side, it will become your IB current. This is your base current. Maybe some current will divide this side. That is your I2 current. This is the currents. Can you see that these are the currents flowing in the circuit? But you should have a common sense here. This capacitor is also connected in the circuit. But one thing is very clear. This current cannot go this side. Why? Because this is an open circuit. For DC analysis, capacitors are not accepting the current because they are in open method. So that's why the current cannot go to capacitor. The current can go to I2, IB. They can go like DC analysis. That's why whenever you talk DC analysis, I don't bother the capacitor path because capacitor side it's an open circuit we are taking. So the currents can go like this only. the collector point, you'll try to get some current here. This current we call it as IC current. You'll get IC current. Okay? This point if you see, you'll get some base voltage here. And you'll get some collector voltage, DC voltage. And you have seen that this current, whatever you're sending down, will be same as this current. But because the problem here is, this side also no current is flowing. The DC current cannot flow this side. The same thing, when this current comes like this current can also not go to the coupling capacitors because it's open circuit. So that is the reason this current is going straight forward from top to bottom, same. Okay? They are not going. Whenever I'm talking AC analysis and DC guide mein hua, okay, we just assume that it is ground. Because for our study purpose, concept mein, we have both the things. But at a time to teach both the things, it will be difficult for a person. That's why to teach one model, other things I have made ground. The meaning is not that the biasing is gone. If biasing is gone, I think these all currents are gone. Understood, yeah? Vidyadas, you'll get some variety of doubts. Okay, for AC analysis, VCC is 0 means we are not considering the DC part, we are considering the AC part, but both are going inside. Okay, for study purpose, according to the superposition theorem, at a time 2 responses are not required to study. One response you can study, that is study. Okay? So come to the point. So DC wise, these are the currents. These are currents going. When this current comes here, can I say that at this point, we'll get some emitter voltage. Emitter voltage will develop, where this current plus this current will divide here. Comes to the emitter point as IE current. This current again will come as IE current here. Because no current will go here, DC current, it will be 0. So this is the way how I am seeing the concept. So when you connect the capacitors also, your currents are not going to the load, it's not going to the signal side. They are enjoying the concept in DC circuit only. That's called DC analysis. Up to here, if you are happy with the DC part, I think whenever I taught you DC analysis, I only consider this circuit. In my book also, whenever they have a complete amplifier model, I said that leave the capacitors and study the DC analysis. Only this circuit is working. It's not working. So that is the meaning called DC analysis. Okay? That load will not come into the calculations when you talk DC part. The signals will not come into the part. And these capacitors will not come into the part because they are open method in DC part. Now you have started one more logic you have to understand. Whenever you said this is open circuit, can I say that this voltage is coming here because the capacitor will try to charge the DC voltage. So here you can see your VC will be blocked in the capacitor. When you say open circuit there, the total voltage what you have in the network will come to that capacitor. That means it is going to charge the DC voltage. So now the capacitor is empty previously, now it is charged to VC. In the similar manner, this coupling capacitor also is going to charge the VB. So now these capacitors are not empty capacitors. Two coupling capacitors have two DC voltages. One is a VB, one is a VC in the class. One is VB and one is VC. Okay? One is VB and one is VC. Up to here the concept is ready. Okay? Up to here the concept is ready. Now the point here is this is being occupied by VB and this is occupied by VC and this voltage across this capacitor will be VE voltage because it is in parallel. So emitter voltage this capacitor will charge. Like this, three capacitors have 3 voltages in the model in DC analysis. So the opening we call it as voltage is stored in the capacitors. So up to here the concept I am expecting it is clear. Okay? Now AC analysis I am starting. The signal whatever you applied, AC signal, I'll take another color for AC part. Let us take another color for it. Yeah. You should distinguish the colors. Yeah. Blue I am taking for AC analysis. From here you started the signal. When the signal enters like this capacitor will work as a short circuit here. So that means for AC it is allowing to enter, for DC it is blocking it. When it blocks it stored the value. Now AC is entered. Whenever the AC is entered, can you tell me how much the voltage will be here? Can I say that this is VB or is only VB or what is the answer is? VIN minus of minus VB will come here. So the total voltage is changing when signal is applied. This voltage has been changed. This voltage is nothing but the combination of these two voltages. So you can write here this value as VIN, this is VIN plus VB is coming here. So your signal is getting added with the base voltage because KVL applied, this minus of this is equal to here. So your signal is getting added with the DC voltage at the base point. When the DC plus AC is added, can I say that here, your base current also will get added. This is small IB. So IB plus IB current will flow in the transistor. For DC, you are getting DC current. For AC signal, you will get AC current. So this is the meaning called coupling we have done. What is the meaning of coupling means? AC, DC we are adding. We call it as coupling. Without the help of this capacitor, I cannot do this one actually. So that's why we got the name as coupling capacitors. They try to couple the DC with the AC in the starting phase. When you couple AC with the DC, your currents also will get coupled. IB plus IB will come. You know that IB into beta times is IC. You got a microamps current into milliamps current in BJT by using DC analysis. Then what I have done is IB plus IB I am sending now. When IB plus small IB, that also will multiply with beta. As base current in DC analysis get amplified to IC, then I think definitely the small IB will also get amplified by beta times. That is the trick in the concept. So DC wise already amplification is going on. Then AC wise also amplification will be going on now because it will multiply with beta. So this current will become here some IC dash we take. It's not IC dash. What is the reason is this current inside will be IC. This is your IC current. This current we produce inside. Outside current is different. So outside current is we can say source current otherwise coming from this current will take it as some I. IC plus I. Here IC plus IC you can write. So this current will be divided into two parts now. IC and one more current here going here is IL current. So we have two currents now. This I is dividing into IC plus IL. Load side one current will go and your IC current will go into the transistor is IC. The overall current will be I here. So you can see this is the technique happen. And this current, whatever you are seeing, IE plus your small IE will generate. But small IE can go to capacitor because it's a short circuit. So I think it will show interest, this IE current, to flow to C. Correctly, if you observe, this current, small I, is not going to capital R. It is just bypassing to this capacitor. That's why it is called bypass. So we kept some bypassing route for that current, AC current, such that when that current, AC current comes, it will not see capital R, it will just divert the route. Okay, suppose you have main road like this, you are going, just I don't want to see the main road to go, I want to bypass it. Therefore, I'll keep some other path for it. So for AC current, that RE effect we don't want. That's why we just kept a SI path for it. That path is nothing but CE path. Whenever that path is created, that IE current will go to CE such that there is no effect of RE, capital RE. So no feedback effect for the AC analysis. This technique is called as bypass analysis we call. For AC, it will go to capital RE, it will go to CE capacitor. So this is the trick I applied. So that, what is the reason for this? Your negative feedback effect is neglected in AC analysis. So that is the main reason why I kept bypass. Negative feedback effect is neglected in AC analysis. That is the work done by CE capacitor. Now coming to this point, this VC is here. Okay. Then whenever you apply AC, I think we'll have some small voltage here. This will become small. V0 you can take otherwise. This is V0. So VC plus V0. VC is not going to the output, but V0 is going to go short circuit. So this V0 will come as your output. So only AC is coming, but DC is not coming to the output. So whatever the signal you have given now, your signal, suppose you have given a milliwatt signal for this. A milliwatt signal you have given. But the current what you have generated, this current is in microamps you generated. But when it comes to the load current, this became milliamps of current because of this DC power. Whatever the DC power you have, that is getting amplified, such that my AC is also getting amplified with that. Such that your output load current is in the order of milliamps. That's why your signal output is also amplified. So I'm expecting the output will come as like this. It will get amplified in volts. And one specialty of common emitter amplifier is whatever the AC signal you have given in phase, this amplifier will go out of phase. And so why sir means for 8 classes, we prove that the voltage gain is a negative. If the voltage gain comes in negative, automatically we'll get 180 degrees phase shift for that. Let us derive that in the next topic. We'll get the answers minus. Therefore, you understand this has a special property called 180 degrees phase shift. Maybe this is the main reason why yesterday class your NMOS inverters has been created because it will invert the output. If you have low, then it will go high. If you have given high, it will go the low value. As a switch, we can use like an inverters. Common emitter is the best inverter. We can make like inverters, but switching wise, MOSFETs are better. That's why in place of BJT, we have studied MOSFET in the previous class as an inverter techniques. Okay. So this is the total game of the concept. Now you should not ask me any doubt related to these capacitors. Why I have used these capacitors means the main reasons I said for you. This capacitor why you kept means to reduce the negative feedback effect. Okay. If you don't neglect the negative feedback effect, the overall gain, otherwise the overall signal output will get reduced because negative feedback always reduces the output parameters. Okay. We have to neglect it. And this capacitor will block the DC and it will send the AC output. So that at the final load, we don't want to see the DC, we want to see the AC amplification. We are not interested in DC amplification. So it will block it and it will send the AC output for you. We have only AC output here. That's why it is called AC amplifier. In this case, we have done coupling. Here we have done some coupling we have done. We have done here coupling. DC plus AC, we done the coupling. Here, we are just decoupling the DC value. We are just decoupling the DC. Here we are blocking it, here we are adding it. Okay? So one side we are deblocking, one side we are just blocking the DC, one side we are adding it. That is common sense. DC wise we already created the power. Just when AC enters, it is getting superimposed and it is getting amplified. But at the final stage, we don't want DC, we want AC. That's why we kept once again a capacitor to block the DC and it will give the AC output. I think this is the beautiness of your concept called capacitors. So now you can think without these capacitors, we cannot believe that the circuits will work in electronics. If anybody misses the capacitors, it will do the side effects for you in the design. Each capacitor has its own importance that you can see in the port. Okay, Vinay Kumar. I understood this workbook video number 14A. Okay, most of the students are getting trouble to open the video. So let us make me to tell them to repeat that video once again. Okay, maybe today or tomorrow they'll try to upload it for you. Don't worry. It get notified for me. Definitely I'll make them to do that. Yes, Ashish, this IL we are getting in milliamps of current. Okay, finally this current is in milliamps. This current is in milliamps. That current is in milliamps. You send in microamps of current. You are amplified in milliamps because of the concept called beta. Here we have a beta current gain of the transistor. That current gain has been boosted your currents. Output currents are boosted by that beta value. Yes, sir. Shabnidas, what you said is correct. Correct. Rahman, a point to understand, bro. This capacitor is blocking the DC parameter. It is allowing the AC parameter. DC is blocked here. It cannot come to the output DC. But AC can go. Here V0 is AC, capital BC is DC. So DC I stopped it. AC I am sending it. That's why I have written the word decoupling. It is just decoupling the DC value. And it's sending the AC value. So Anupam Das here, AC current is not coming from the supplier. AC currents are coming from IC and I. These two are generated by these currents. Okay? If you see the board, this current is coming from VCC or C, but not VCC. This current is a division of these two currents. Okay? वो current divide हो रहे two currents में. One is IL current and one is I current. Because in AC analysis, this will get grounded, so these currents will divide into two parts. This whole IC current. Okay? AC is not creating any, DC source is not creating the blue color points. Blue colors are all coming into AC analysis. So in my board, all blue colors are AC techniques, green colors are DC techniques. That's the two different colors I have used. So neatly write down the points I think. I think you must be able to understand daily in our classes why we take coupling capacitors and why we take bypass capacitors in our classes. Daily I will not teach you this capacitor story. It should be in your mind now. While you are taking, each and every point have been cleared off in this board. Okay? Vishal, DC current, where it will go? What's that question here? ये पूरा DC current है ना? ऊपर से नीचे जा रहा है DC current. किधर जाएगा? वो बोर्ड में clearly लिखा है DC current. It is going from VCC to ground. The DC currents are flowing because capacitors cannot accept the DC current. Only blue color lines. There is AC currents only. The capacitors are accepting. Yes, Akash Mitra, perfectly you said. We are giving VCC to bias it. Perfect. Because it should be in active region first. And after that, the BJT, VN is giving us an input. So first we are not giving input signal. Common sense apply करो. First bias कर रहे. If you don't bias it, your transistor will not be on. If transistor is not on, signal देकर आप क्या करेगा? So signal is a word comes after DC part. So first you have to teach DC, next you have to teach AC. Never teach first AC and come to DC. That's why we have completed 3 days. Only DC part we covered. Not 3 days, 4 days it has taken. BJT MOSFET 4 days it has taken to cover DC part. Next we started the AC analysis. Okay, at least you must know the common sense points. First to DC, next we have done the AC part. Okay. शमनी दास तो टेंशन नहीं लेना. IC is equal to I ले सकते हो और IC is equal to alpha E ले सकते हो according to the alpha value. Okay. Arka, I think decoupling is nothing but the DC plus AC we are getting output at this point, collector point. We don't want the DC there, we want only AC. So capacitor if it will block the DC. It will just open circuit for DC, so it will block it. But AC, it will go directly because capacitor is short. That is a meaning called decoupling. Okay, decoupling is nothing but disconnecting the DC to the output. We call it as decoupling. Anyway, I think this much time is enough to spend the concept on this. Let us start our final journey today. How to calculate for common emitter and common emitter bypass, how to do the analysis, and common source and bypass. Lambda equals, VA equal to infinite, VA equal to not equal to infinite. Two cases I have to explain. So let us start doing two analysis now. Amplifier analysis I am doing now. Amplifier analysis. So start the calculation part. First we'll complete the common emitter bypass. We are doing common emitter bypass amplifier. They will not take much time here, very simple topics. Common emitter bypass amplifier. First case we'll do for VA is equal to infinite case. I'll make two cases of this. VA equal to infinite. Common emitter bypass. Nothing is there. First you write your model. Suppose if I want to write R pi model, I'm writing. This is R pi model I'm writing. R pi, make it ground. And the other side we have current source. GM into V pi. Here ground keep it. And this is your collector. This is your base. And this is ground point, which is your emitter. If you clearly see, your transistor has been replaced in your amplifier model. Just up the transistor model I kept first. This is called transistor. Now I have to create a AC model for this to study the class. AC model I have to create. One time go back and see, step by step you can see. So this part I covered in the class. Okay, a transistor go, take it outside and keep R pi model here. From base to emitter I kept R pi. From collector to emitter I kept a current source. Completed the story. The next onwards, क्या करना देखो. Here emitter to ground, this RE is getting shorted here. AC analysis now, we are doing RE parallel to CE. CE is short circuit in AC part. Then automatically this point to this point is coming same. So that's why emitter I treat it as a ground in the class. Because RE effect is 0 in the class. After that, what we have is, these two resistors are there, where VCC is ground for AC analysis. VCC is ground for AC analysis. That's why these two resistors, if you take, this is ground, we can take parallel, R1 parallel to R2. Therefore here we can get R1 parallel to R2, which is RP you can take here. This R1 will bend like this, because this is ground at the time, in AC analysis. In AC wise, this is ground, so R1 will come parallel to R2, and this will become short circuit, and this will be signal. So, that points I'm writing here, you can see. You have here we have some RP will be there. This is RP, and here we have the signal. So throughout the classes, this is the story at input. You will get some RP will fall to the ground, because your VCC supplies ground here. That RP is nothing but R1 parallel to R2 resistor. After that, coupling capacitor will be shorted, signal will be there. Now come to this side now. This side, what will be there? If you come to this side, again go back. Here there is a short, here we are making short, one load is there, and this RC is grounded here. So these two resistors will be parallel because this is one ground is there, here one ground is there. That's why these two resistors will come parallel to each other. This will come parallel to this. So just to join here, a parallel combination. Just keep some name for this. Okay? You can keep some name, RL dash. Some load is there, RL dash. And you take this as your output. So where, indication you can write, where RP you can define in the problem as R1 parallel to R2, and RL dash you can write it as RC parallel to RL. This is the story. Actually this is ground becoming because here VCC is ground, here VCC is ground. That's why the resistors has been bended to the downward direction. So this is the simple model called common emitter bypass model. Just take down up to here. We'll do the characteristics, that is input impedance, output impedance, all these things easily you can find out. So note down up to here. Note down up to here. So friends, I got some information from my technical team that they have been re-uploaded the 14A video. Okay, maybe I'm expecting evening you will get it. Once again, you recheck at evening around 7 o'clock or 8 o'clock. Okay, the video will be open for you. If it is not opening once again, just message me tomorrow again. Compulsory it will open because I rectified the problem and re-uploaded. 14A is re-uploaded, so no worries. 70 how you have taken R pi and GM into V pi. ऐसे नहीं बात करना यार. अभी तक हम BJT में क्या किया अभी तक? BJT model we have created or not? Whenever you have a BJT model, BJT को replace करने के लिए we have studied till now. Just that BJT I replaced first. This is BJT. After that, these are the extra things we applied in AC analysis. Okay? Extra things we applied it. Just complete karo, the duct. Just 1 minute, I'll come. Doing the problem is very comfortable and easy. They'll ask you only 4 questions for you. But now presently I'll teach you BJT wise here. So we'll have 4 questions we can do it. We'll do 4 questions now. What is the question strategy? The first question here is, I can ask you, the input impedance is the first question. You can see. Point number 1. Suppose somebody asks you, please calculate the input impedance in the problem. ZIN I want. Okay. When I want ZIN, you have to see from here, from the model. This is your ZIN, input impedance. Then directly you can solve this problem as ZIN will become your biasing resistor RP parallel to your input impedance of the transistor called RP. So this must be the input impedance of your amplifier. So one time who knows the modeling, okay, doing the problems are convenient for us. So this completes my input impedance in the problem. These two resistors parallel combination is my input impedance. Okay. What is the next formula here is? What is the output impedance if you want output impedance? If you want to find output impedance, I said one rule for you. There is some rule for output impedance. What is that? The source should be ground. That means here my input signal, you have to make it ground. Therefore here we have RB. This is RB. Next we have here RP. Next we have current source. GM into V pi. And this is your collector. And we have the load. RL dash. This is your output. So what I am doing here, to calculate the output impedance, the input should be 0. The input should be 0. The input I have made it as 0. When the input is 0, here, can you see that what is the output impedance seen before the load? Means RL dash, make it infinite and find out how much the impedance will be. Now when input here is 0, can I say that your V pi, whatever you are seeing, will become 0? Because this is ground, there is no voltage on both sides, so V pi is 0. When V pi is 0, GM into V pi will be 0. So the current source is getting 0 means it's open circuit current source. So we can say that if you want here some, what you can say, Z0 output impedance from here, it is coming as infinite. If you say from here, the current source is getting 0 means open circuit, so Z0 is becoming infinite. So if I want to find from here, you take some notation for this, otherwise Z0 dash you can take. If you want Z0 from here, the answer will be RL dash parallel to infinite. So that answer will be RL dash is nothing but Z0. So this is the way how you got Z0. Whatever the RL dash is there, that will become your output impedance here with this principle. So second point is clear. Next point is how to find out the voltage gain. Can you see that this current only going upward like this? This current only going upward. So that you can keep here plus, here minus. So what is output voltage here? If you want to calculate the gain, what is output voltage? You write first. Your output voltage is minus GM times of V pi into RL dash. So current into resistance is output voltage. Correct? So what is V pi here? Your V pi, whatever you are seeing, is parallel to the input. So it becomes minus GM into input into RL dash. So your input and V pi both are same. Therefore, your gain is nothing but output by input is equal to minus GM into RL dash. Can you see that your gain is coming negative value? If the voltage gain comes in negative, what is the meaning of that is? It will go 180 degrees phase shift. That only I have written in the class. Your signal will get shifted by 180 degrees because common emitter gains always comes in negative value. If negative is not coming means you are doing some mistake. Common emitter always gives negative gain. And you can see how simple the derivations we can do it. Minus GM into RL dash. Let us practice the session like this, writing the diagram and investigating the formulas. Last point, current gain you want. Final point here is current gain you want. Last point is current gain. So what is I naught here? You can take this current as I naught. Okay? And this current will take it as IB current. And this current will take it as IA current. So these are the currents you are seeing. So seeing the board, what is I naught? Is equal to GM into V pi. You can write it as I naught in the board. This current and this current are same. Output current. And input current is IA. Is dividing into two currents here. So first can you get IA if you want with respect to IB. How to get this current is? First shall we calculate first IB in terms of IA. By current division rule we'll find out. So first IB will find out. IB is equal to total current into opposite resistance, that is RB, divided by RB plus R pi. So this is your current division rule applied. IB to IA. But what is current gain here is? What is the current gain formula here is? Current gain formula is AI is equal to I naught by II is the formula. Current gain is output current by input current. But we know II is nothing but this formula you can write. So GM into V pi divided by, it will become IB into RB plus R pi by RB you can write. Okay. Then how to cancel these terms? Let us see how to cancel this term. GM into V pi is there, divided by IB. So what is V pi? In the board you can write. Here V pi, you can write it as IB into R pi you can write. Let us write this one. GM into IB into R pi. Divided by, V pi can be written as IB into R pi I have written. Divided by IB into RP plus R pi by RB. Such that IB you can cancel. IB you can cancel. Okay. Finally, how to bring in a good manner, I am seeing this concept. Okay. Let us write the final issue now. Let us write a small conclusion. I need some more calculation. So whenever you get this answer like this, see here, there is a term called Gm into R pi is there. Can you simplify this term, Gm into R pi? Is there any other form you can write that term, which I am saying in the numerator? Gm into R pi means we can write like this. Gm is nothing but the formula. Gm is nothing but the formula 1 by small re. Correct? R pi is nothing but, you can write it as 1 plus beta into small re. So R pi can also be called 1 plus beta re. Already I concluded in my RE3 modus. And Gms can be written as 1 by dynamic resistance. So if you cancel this term, so the formula is Gm into R pi can be written as simply 1 plus beta you can write. So this is called Gm into R pi. So you can write that term here. So here one thing you can simplify that, as beta is much greater than 1, you can write Gm into R pi, simply you can write as beta. 1 plus beta is not required, because if beta is 100, like this if you take, you can neglect the 1. Current division rule applied, IB to IA. But what is current gain here is, what is the current gain formula here is? Current gain formula is AI is equal to I naught by II is the formula. Current gain is output current by input current. But we know II is nothing but this formula you can write. So Gm into V pi divided by, it will become IB into RB plus R pi by RB you can write. Okay. Then how to cancel these terms? Let us see how to cancel this term. Gm into V pi is there, divided by IB. So what is V pi? In the board you can write. Here V pi, you can write it as IB into R pi you can write. Let us write this one. Gm into IB into R pi divided by, V pi can be written as IB into R pi I have written, divided by IB into RB plus R pi by RB, such that IB you can cancel. IB you can cancel. Okay. Finally, how to bring in a good manner, I am saying this concept. Okay. Let us write the final issue now. Let us write a small conclusion. I need some more calculation. So whenever you get this answer like this, see here, there is a term called Gm into R pi is there. Can you simplify this term, Gm into R pi? Is there any other form you can write that term, which I am saying in the numerator? Gm into R pi means we can write like this. Gm is nothing but the formula. 1 by small re. Correct? R pi is nothing but, you can write it as 1 plus beta into small re. So R pi can also be called 1 plus beta re. Already I concluded in my RE3 modus. And Gms can be written as 1 by dynamic resistance. So if you cancel this term, so the formula is Gm into R pi can be written as simply 1 plus beta you can write. So this is called Gm into R pi. So you can write that term here. So here one thing you can simplify that, as beta is much greater than 1, you can write Gm into R pi, simply you can write as beta. 1 plus beta is not required, because if beta is 100, like this if you take, you can neglect the 1. High betas if you take, 1 can be neglected. Okay? Above 50, everything is greater than 1. So you can write simply this answer as current gain is equal to simply beta into RB by RB plus R pi. So this is the way how he brought the current gain formula. Current gain formula is simple only. Beta, whatever he has given in the exam, you take that value into, just apply the current division rule of this formula. RB by RB plus R pi, you have to write that, multiplied by that value. So this is about the story. When this concept is LA voltage is infinite, we are doing the problem like this. So this is a complete content for you. Please complete it. Today we have to finish off bypass at least. Bypass pura complete ho jayega. So total analysis is in the board, you can see. Just I'm magnifying it. Yeah. Just note down quick here. Okay, Aditya, that's why I magnified the screen. You can just watch. And side by, you can see the total screen now. So most of the times, please avoid seeing the video class in the mobile. Okay, use laptops or you can use tab. Maximum use that one. Whenever it is difficult at the time, you can use mobile. Unnecessarily don't use mobiles, because for a long time you cannot see the small screen like that. Rahman here, this current is coming like this here. This current is not going to this side. This total current is going I not like this. This current is not coming here. This current is this current coming in. It's coming from here. This is the total current coming from the ground to the load. Okay, from the ground to the current is coming to that point. It's moving like this current. It's not moving like this. Okay, we not say moving over here because there is no load connected there. From where it will come that current. Yes, you know, the output impedance is infinite up to here. After that, you take this as from here. If you calculate, this total answer will be the output impedance. So before the load should be open. After finding, you keep the load and see the final answer. Okay. When you are solving here, from here, this is not required at the time. That's why I said RL dash should be infinite. Thus इसने बोला यार GM कैसे 1 by RE हो गया, because RE is a dynamic resistance, GM is called dynamic conductance. Dynamic conductance will be inverse to the dynamic resistance. Okay, इनमें derivation भी नहीं चाहिए. It's a common sense point. A dynamic conductance will be reverse to the dynamic resistance in the class. That's why GM, whenever you see in the classes, you can write it as 1 by small RE in the classes. Okay. I just simplified this term here and I have written in the formula. Okay. Finally, I understood Gm into R pi can also be written as beta. That is the simplification we have done it. Okay. So I'm expecting it's completed. Next we'll go for a BJT2 MOSFET class. MOSFET wise, if lambda is 0, how to do the analysis? Okay. If lambda is 0, how to do this analysis? If lambda is 0, how to do the analysis? Yeah, Majinder, either no voltage, so no current. So V by 0, this is 0. So current source is 0, meaning it's open circuit. So I said infinite. If current is 0 means we should not take short circuit, we have to take open circuit. Dipyadas here, Gm means 1 by Rp here, it's 1 by Re. Okay? It's 1 by Re we have to take, not Rb. You're going in wrong direction. Rp is called base dynamic resistance, but the Gm is defined for emitter dynamic resistance. Okay? Gm is 1 by Re, not 1 by Rp. So let us start doing the MOSFET analysis. So next is you can write for common source bypass amplifier. You can write it as common source bypass amplifier. Keep here lambda is 0. I already told you the language is opposite here. In case of BJTs we say VA is infinite, but in case of MOSFETs we say channel length effect is neglected, called lambda is 0. But ultimately lambda is equal to VA. Okay? Sorry, lambda is equal to inverse to VA. So language will be slightly different. Here lambda equal to 0 we'll say. Dipyadas, if you want to know Gm is 1 by Re how it is, proof दिखाता हूं आपको, थोड़ा wait करो. एक concept होने के बाद I'll show you the proof also if you want. थोड़ा confusion avoid हो जाएगा. एक topic होने के बाद एक small step I'll explain. Why Gm is 1 by Re, I'll prove it. CS common source bypass amplifier. Lambda is 0. So you know that the model for MOSFET will be like this. What is the model is? This is gate. Okay? This is source. We have VGS, gate to source. It's an open circuit. And we have here current source. Gm into VGS. This is your drain. This is called FET replacement. MOSFET replacement KMI. Input is open circuit. Output is a current source. Okay? Other things are common. Whatever you studied till now, same thing. What is that? Here, there will be some biasing resistor will come. Maybe in MOSFETs we call this as RG, we call gate resistance. Here we have some input. Like BJT class only you do it. Here we'll get some load. That load is here RL dash. I've seen the beautiness. Everything is same here. Here load you are connecting, here biasing resistor you are connecting, input is applied. So the story here is where your RG resistance is nothing but R1 parallel to R2. And your RL dash is nothing but your drain resistance parallel to load resistance. These are your indications in this problem. Now finding the answers are very comfortable. The first question, if I ask you what is the input impedance, seeing the board you can tell the input impedance is RG parallel to infinite. So that input impedance will be equal to simply RG. So your biasing resistor will be the input impedance. So the biasing resistor will become the input impedance for this problem. Okay? This is the first answer. Because infinite parallel to anything will be, that answer only will come. The second one, your output impedance. Output impedance. No need of doing this. Your input is 0. Here we are doing input is 0 condition. Then automatically VGS will become 0. To find out the output impedance, input should be 0. If input is 0, VGS is parallel to input, that is 0. So Gm into VGS will also become 0. Gm into VGS will become 0. Now what is the output impedance here is simply, it is infinite parallel to RL dash. So answer will be RL dash. So same answers we are expecting for BJT classes and MOSFET classes. Because the same answers, only slight difference is here. There are RG, RP parallel to R pi. Here RG parallel to infinite. That is the difference we are getting. And coming to the point number 3, voltage gain if you want. V0 is equal to voltage gain you want. This current you can take. This current is your I0 current. So we can write V0 voltage as the current is flowing in this direction. So plus minus. So V0 is minus Gm times of VGS times of RL dash. But your VGS and VI both are same. So V0 is equal to minus Gm into VIN into RL dash. So output by input, the gain is minus Gm into RL dash. Why you are studying in analog? Two different transistors, both are giving same knowledge. That's why if I know one transistor, the other transistor automatically I do it like this. So you can see the gain formula is same, output impedance is same, input is slightly different because there's a low impedance device, there's a high impedance device. Slight difference will be there for input. The remaining things I'm enjoying it. And I think you can keep some small note. Current gain calculations will not be done in MOSFET. So this is an advantage for you. We have only 3 parameters to solve in MOSFETs. Current gain is not required because it's a high input impedance device called open circuit input. If there's an open circuit input, there's no input current, how will you find out the current gains? So I think in MOSFET classes we have only 3 calculations. Examiner never ask you, please calculate current gain in MOSFETs. They can ask you current gain only in BJT classes. So this is the story here. With this we have completed the common source bypass amplifier. Give me some 15 minutes time is there. We'll cover lambda not equal to 0, what happens? And if it is VA not equal to infinite, what is the result will change? Just we'll conclude it. And we'll stop this analysis today. Tomorrow class when I come morning 8 o'clock, we'll start with common source unbypass and common emitter unbypass. That will become the 4th topic. Next after that we'll continue with active load concepts. Lastly we'll cover the frequency response. Tomorrow complete job of amplifier CE and CS should be completed. Tomorrow that is the target. Okay, because the workbook lot of questions are there. Each and every question I have to explain. Then only your grip level will increase. Only teaching like this, and if I don't teach the tricks for you, the examiner guide us. If I don't teach in the workbook, the total subject what I thought is waste for me. So I have to teach each and every question inside the meaning, how the examiner will think, and what is the logic behind that. Each and every step I have to teach in the workbook. Workbook itself will take some 2.5 3 hours class. That's why first we'll complete this content tomorrow morning, at least by 1 o'clock if you complete all these things. Afternoon we'll spend the time only on problem solutions. Okay, workbook problems complete. So tomorrow we'll do that work. Day after tomorrow morning session we'll complete common collector. Afternoon section to Friday, you can expect analog will be completed. Op-amps will take 5 days, so analog will be completed by next to Friday, according to my knowledge. Yes, sir. Shabani, what you said is correct. If the input is open, we will not calculate AI in the concepts. Okay. And Divya Das has some doubt here. GM is 1 by RB or RE. ऐसे बताना और trick. So I'll give a short point for that. You can write some short practice for the formula. कैसे लिख रहा हूँ वो technique. The technique I'll explain you. Yes, Lahari, Medis may holidays don't ask. Okay. We generally don't take holidays. You also don't take holidays. But when they give holidays, we have to enjoy it. Okay. Tomorrow is no holiday. Our class is going in a similar manner. Okay. 2nd October is tomorrow date. We know 2nd October is for the normal basic people. They'll take holidays. But we are hardworking students and hardworking faculties. We never take holidays. Daily we'll work. Okay. So whenever they give holiday, at the time we'll be free. Until unless we enjoy in subject. We'll enjoy in subject. Tomorrow no holiday, my friend. Our class will be in the same routine process. October 2 आप क्या करेगा? Holiday लेकर आप क्या करेगा? Because time is coming on. Gate is coming very close. You should not think about holiday daily in the class. Okay. Daily you have to work hard. Until unless the exam is completed, you should not think about holidays. By chance if they give holiday, at that time you can become free. Until unless, don't think about that. Okay, Lahari, no problem. You can take the vaccination. Tomorrow you can go. Nicely, you can take the vaccination. But vaccination will not take the total day, I think. Hardly takes 10 minutes. Oh, vaccination later, you can come and you can listen to the class. Because after vaccination, nothing will happen here. Some people are telling fever will come. But if your body is having good stamina, no fever, nothing. Do you know that after taking vaccination, I came here to teach 12 hours class. Okay? Nearly 10 hours something. Approximately 10 hours I thought. Vaccination later, I have thought without taking rest. I have thought 10 hours daily. So it's not the meaning of that. Whenever you have taken vaccination, you're sitting at home only. Just only you're listening to the class. After the class, you can take rest. Otherwise, you have to see the recording video. That is the only problem you have. Yeah, Bose is telling the correct statement for me. Lifetime holiday after gate. Perfect. Perfect, you said, my friend. One time your target is reached. After the daily holiday for you. Okay? Whenever you settle in a job, okay, comfortably you are earning. At the time you are free, your life. Nobody will ask you how many days you want, you can take holidays. You can enjoy your life. Okay? Until unless you do the hard work always. So this completes the story. I think GM story tomorrow I'll explain you. Let us complete that 2 more points. First I'll finish that points so that this topic will be completed. Let us complete the remaining part, which is simple points. That is a common emitter. Again, repeat the concept. Bypass. Common emitter bypass. Take the analysis. Common emitter bypass. Common emitter bypass amplifier. Common emitter bypass amplifier. Where we have here VA is infinite. VA is not equal to infinite. VA is not equal to infinite. In this topic, please remember all the characteristics will not change. Only one parameter will change. That is output impedance. Whenever the questions comes like this, their interest is to understand what is the output impedance for that. Whether it will change or same. Remaining things you will enjoy same. If you want, you can see here. Remaining things will not change. This is RP. This is RP. This is VIN. We have RPi. We have current source. GM into VPi. Next we have one R0 we have to keep here. And we have to take the output as a load here. So only thing is here RL dash. This is your output. The only thing is one extra R0 is there here. So what is the difference will come here? Is there any difference means? Yes, small differences are there here. If you see from here the board, your input impedance, ZIN, will be same. RB parallel to RPi. There is no disturbance for this content because you are talking here. When you are talking here, can I say that your output impedance will change? It will be changing as R0 parallel to RL dash. So this is the content will change. You will get R0 extra parallel to RL dash. Previously that R0 we have taken as infinite, but now R0 is existing there. So this formula will change. Okay, this will be same, but this is changing. And what about the gain here? If you see, gain formula, that is voltage gain. You will get a V0 formula if you write first. This total take it as parallel combination. So minus GM into VPi into R0 parallel to RL dash. So this is the formula. So it will become minus GM into VIN R0 parallel to RL dash. So the gain will become minus GM into R0 parallel to RL dash. So whenever you have some early voltage, the problems are slightly different. This will change and this will change. These two formulas will change. So you can write here, there is no change in this concept. Input impedance, there is no change. But there is a change here. In this formula, there is a change. In this formula also, there is a change. So theoretical to practical, there is some small changes. So this is about the story. What are the changes you can see? If I go for the same story, common source, bypass. So I will show you common source bypass. Of lambda, suppose not equal to 0 you said. Then the model will be, this is RG, this is VIN, this will be gate, this is ground, VGS. We have a current source, GM into VGS. After that we have here R0. And finally we have the RL dash. So you can see the same structure, you can see here also. Rahman, you said nature truth you said here. It's a nature truth. Perfectly you said. It's a perfect statement. After death to only holiday, nobody will disturb. Perfect. It's a perfect statement. Nice statement. Really, whenever we have life, maximum we have to do hard work. Okay? Whenever we have the freedom, then we have to sleep. Because God has created us not to sleep. Okay, sleep time will come. Whenever it comes, we'll sleep happily. So common source bypass. If lambda is not equal to 0, what will be the answer? Very beautiful statements you are telling. A real truth you understood life. This is RG, which is no change. There is no change here. Your input impedance is RG. There is no change. And coming to the point here, what is the output impedance here? output impedance. If output impedance, if you see, it becomes R naught parallel to RL dash. There's a change here. There's a change. And coming to the last point, gain formula, it is minus Gm into R naught parallel to RL dash. There's a change here. There's a change. Okay. So some students are asking, sir, what about the current gain in BJT class? Generally here, these are comparisons we do. Current gain के लिए बात नहीं करते. If you want to do current gain analysis, what is the change you are expecting? No change, because the formula is beta. So beta is beta only. RB by RB plus that value, that are input parameters. It will not change. Only these three concepts you can see. Voltage gain will affect, output impedance will affect. So current gain was same formula, same action. Nothing to disturb you. You can take the same analysis. So these are the extra things a student should understand it. When the examiner gives intentionally this problem, how to approach this technique is, this is the small techniques. Only thing is, R naught parallel to RL dash you have to take. When Z naught becomes that one, in the gain also we have the same factor. R naught parallel to RL dash. So this completes successfully today class. 3 topics I covered in the lecture. Total 6 topics I have written in my board. So 4th topic is tomorrow. We'll set 4th, 5th and 6th 3 topics. Tomorrow topics are very interesting topics. Let us finish the complete approach and we try to start doing the workbook problems step by step. Okay? Afternoon class we'll do the workbook. So tomorrow also I may not take much time. 8 we'll start the class. Early of 4:30 or 5 we'll try to stop the class. So that somebody is saying holiday. After 5 you can enjoy your life. Okay? So tomorrow also we'll take up to 5 o'clock, 4:30 or 5 max. Tomorrow my intention is to cover the common emitter and common source. A complete analysis should be completed tomorrow by tomorrow. Day after tomorrow we can cover in Sunday class other 2 amplifiers nicely. They will not take much time. Only this amplifier will take more time to teach. The remaining things are easier. Yes, thus after op amps, there is a negative feedback analysis will be there compulsory. There are 2 different modules I have written in my syllabus. Step 11, step 12 is that only. Step 11 is negative feedback analysis. Step 12 is oscillators. There are 2 different modules. Okay, Harsh, thank you very much. Till then you can become free today 4 o'clock. You can become free. You can take rest for some time and start working. Okay, take some time, refresh and make enjoy. After this, start preparing the subjects. Maybe that video, 14th A video has been uploaded one more time. Evening one time, open it and see that. Whether it's working or not, but confirm that I'll come morning. So tomorrow class timing is 8 o'clock. Again I'm writing here because of some students. Tomorrow class timing is 8 a.m. 8 a.m. is tomorrow class. Tomorrow class, 8 a.m. Okay? So let us stop here. Thank you very much for today's class. Last 2 modules in GATE AC. Okay. Chalo then, the proof if you want. Tomorrow when I come back, tomorrow I'll explain that. Okay? Today time is over. Some other faculty has to engage this board. I'll stop here. GM I remembered. Tomorrow I'll explain you. GM. No worries. Tomorrow I'll explain you. No worries. Yeah, Ananya, after op amps, after covering the standalone syllabus, okay, I'll not take much time for EDC. I take just one end of day class. To cover first one day, total PNX theory analysis I'll teach you. Because for electrical students, total depth is not required. Fundamentals are required. That basics I'll explain for one day. And I need half day time for PJT design calculations. MOSFET and JFET already covered